Welcome back to Redstone with Dave.
And Baker. Hello. So now we'll get into comparator and hopper clocks. So the three uses of comparators, sort of like the three important uses in my opinion, are seeing how full a container is, like for sorters and for minecart unloaders, clocks, and as pulse extenders. So, but the reason they can become clocks and pulse extenders is because of their comparing feature that they have, right? So this is a comparator clock. It's really easily toggleable. When I turn it on, it's going to spam, and this dispenser is full of arrows, and it's going to shoot a lot of arrows.
Nice.
Pew, 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 pew. And so if you notice that lamp, so if you watch the lamp, you'd think it would flash on and off really quickly.
Yeah.
Right? Uh-oh. Voxel Sniper.
Yeah.
I've got a plugin that uses an arrow as a tool. So I clicked on the lever with an arrow, and it just destroyed the lever. So the lamp doesn't turn off, though, because this clock flicks on and off so fast that the lamp actually needs a little bit of delay to turn off and on.
Okay. They're sticking into the signs.
Yeah.
That's funny.
These armor stands plus the arrows is a little bit glitchy, but we'll ignore that for now.
Cool.
Because those arrows will despawn.
Yeah.
But basically, the way this works is this comparator is powered by the lever, right? So 15 signal strength. This comparator is on subtract mode. So it's subtracting from this 15 whatever it gets as an input on this side.
Okay.
So right now, there's no power. So the first time it outputs 15, 14, 13. So once it gets powered over here, and that happens in one tick, the comparator takes one tick to process it, and then turns it off, or applies the subtraction. So now, instead of outputting 15, it subtracts 13, which is this side input, from 15, which is the lever input, and gets 2. So you get 1, 2. So these two are powered.
Okay.
But now there's nothing to subtract from. So in the next tick that it processes, it says, hey, I'm not subtracting from anything. I should just output this whole 15 that I'm getting from the lever. And it outputs all the 15 again. Right?
Yeah.
Whole 15. And then it has to subtract. So 15, 14, 13. Because that's how the dust powering works. And then once it gets to 13, it realizes, oh, okay, I need to apply subtraction again. Now it only outputs 2 signal strength, which isn't enough again. So that's the constant loop, and it just happens really quickly. Okay. So the redstone lamp was not flickering, but if we extend this dust fast enough, I'm 90% sure, and I'm going to take the arrows out of the dispenser, that it now, oh no, it's still, because redstone lamps need a second to process that. But you see how this is sort of always on, but this one is flickering?
Yes.
That's because this one is going from max power to slightly less, because it's still getting that 2 power, so it's going from 15 to 14 to 1 really, really quickly, because it's the 15 from here, and then it goes to 14. And then when the subtraction is applied, it then goes from 14 to 2, so this one goes from 15 to 2. And so then instead of 14, it only has 2 power next to it, so it turns to 1. And then this one flashes between 0 and 13.
Okay.
Right?
Wow, okay. This is getting pretty complex, Baker.
Yeah. Well, it's just sort of hard to explain that well
Yeah.
because it's just sort of happening so quickly.
Yeah.
And if we had like the mod that could slow down tick speed,
Hmm.
that's not something.
I see. Okay,
So
cool.
next,
I'm
we'll
gonna
get
I'm gonna have to
into.
rewatch this video a couple times.
Well, do you have any questions? Just because this comparator clock understanding it is kind of weird, but basically all you need to know to make it is comparator block or just like power source, redstone, redstone, redstone. Oh wait, this doesn't work. Why? Because it's not subtracting, and in order to make it subtract, you have to have this little light in the front on, and that
Okay.
indicates it's subtracting. And the way you do that is you right click.
Okay, that makes sense. Okay,
Yeah,
cool.
and so now you can see that these are sort of constantly powered. So if we have a piston next to them, it's always on. But this one, well, it's there's nothing that can really accept the tick speed that fast, except for dispensers.
Okay.
So that's why I used the dispenser to show that it was flickering.
Right.
But you can also see in this case that this is the one that's flickering and this is the one that isn't. So
Right.
if I put 25 arrows in here, it doesn't do anything because it's still always powered. But this one gets the toggle. Oh, and it's just it's next to the lever, so I need to move it over here. So the reason it didn't work, so this is like knowing about how redstone works and how so that you can fix your stuff,
Hmm.
is because it was powered by the lever. So this
Okay.
toggling on and off was happening, but it was already powered by the lever, so it couldn't register anything else.
Gotcha. Okay, cool.
So if I put 25 arrows in this one, it flicks up and down. But it hits the armor stand, so they just...
Chaos. And chaos ensues.
Pretty much.
Nice. Okay.
Now, we'll go on to comparators and hoppers used as pulse extenders. So this is a basic pulse extender. We sort of had a version of it over here. This is a slightly better version because I actually forgot how to make the good version when I did that video.
Hmm.
Sorry. But this is the better version. But basically, if I press this button and you look at the two lamps, you'll notice that this one turns off a lot more before that one, right?
Yes.
So that's because this pulse is being extended so that this lamp stays on for long. And the way that happens is this button powers both this repeater and this repeater. And this repeater just goes straight through and turns this lamp on. But this repeater takes a bit of delay and then powers this redstone dot.
Okay.
And then this repeater also powers this repeater, which takes a little bit of delay and then powers the redstone dust next to it.
Hmm.
And then this repeater takes even more delay because it's delayed because it's only powered by these repeaters here.
Yeah.
So in order for this one to get powered, first this one has to take its delay, this one has to take its delay, and then this one gets powered.
Okay.
So this redstone dust running alongside doesn't power any of those.
I see.
So delay, power, a little more delay, keep it powered, a little more delay, keep it powered, and then all the delay runs out.
Okay. So then what is the redstone on the side actually doing?
It carries the initial current, right,
Okay.
from this repeater.
Okay.
And this red repeater powers this block, which powers the redstone next to it,
Okay.
which
That makes
keeps the
sense.
signal going again. And then after the next delay, this block is powered, which keeps the signal going in this wire again. And then this one powers that block,
Hmm.
which powers the redstone dust next to it and keeps the signal.
Cool. Okay.
So, but we can make much better versions with comparators. Comparators are expensive because they take quartz, but we can make better versions. So this is an example of 2 pulse extenders using comparators of varying length. Right?
Let's see that one more time from a bird's eye view. Okay.
So this one doesn't take quite as long. This one takes a longer time, and then this lamp in the middle is just being powered by the button.
Okay, one more time.
So I'll just label them with wool and how long they take. So red is really short, green is really long, and yellow is medium.
Oh. Okay.
So they all turn on at the same time. This one's off first, then this one, and then this one.
Okay. Cool.
So
that is much more efficient.
Yeah, it's much smaller, isn't it?
Yeah.
And it lasts longer. So the way this works is because comparators take a long time to process things, and then they also keep the signal that was given to them. So if you had a long line of comparators, and then you were to give it, say, 3 signal strength by filling a hopper with 1 stack of green wool. So we're now transmitting a signal strength of 3 to these comparators, and our output is a signal strength of 3 all the way over here. Right?
Yeah. Nice.
So the unique thing about this is that repeaters just reset the signal. So that just resets it to 50. That's what repeaters do.
Okay.
But comparators are a little more careful, and they keep the exact signal that was sent to them. So it's 3 signal strength here. It says, oh, hey, what'd I get from this guy? 3. Okay, so I'll power 3. And then this receives 3 power. Okay, 3 power, 3 power. And then finally it outputs 3 redstone signal strength of dust.
Okay.